Welcome to EduSwift. This is the continuation of the last session. Here we will solve intex 2. Again, set of 5 questions. Okay, the first one is name few important periodic properties. So answer is atomic size, ionization energy, electron affinity, electronegativity, metallic character and non-metallic character. These are considered as very important periodic properties. Okay. Next question, second one. Size of the atoms of inert gases are more than that of halogen. Give reason. So we know that atomic size decreases as we move from left to right in the periodic table. If that is the case, group 18 elements, inert gases, should have least atomic radius, but size of 18 group elements are more compared to the halogen. This is because outermost shell of inert gases are completely filled. Valence shell is completely filled and they contains maximum number of electrons in the valence shell. If the number of electrons are more in the valence shell, repulsion will be more. If the repulsion is more, then size expands. Okay, so that is the main reason that the inert gases have more atomic size compared to halogen. Outermost shell is completely filled, therefore maximum number of electrons in the outermost shell, which causes more repulsion. If the repulsion is more, size will expand. This point you should remember. Okay, next, third question. What are isoelectronic ions? Give example. So the ions having same number of electrons but different number of protons are regarded as isoelectronic ions. Same number of electrons, they should contain same number of electrons but different number of protons. For example, consider O2 minus, N3 minus and F minus. This is example for isoelectronic ions. In the first ion, you see O2 minus. So it has gained 2 electrons and its atomic number is 8. So 8 plus 2, it contains 10 electrons. Second one is N3 minus, nitrogen atomic number 7, 3 minus, so 7 plus 3, 10, and fluorine atomic number 9, so it contains 9 electron, but here it is F minus, so 9 plus 1, 10 electrons. All these ions contains the same number of electrons, 10 electrons, but protons, it is different. Number of protons are different. So it is example for isoelectronic ions. Okay, next question, fourth one. Write the variation of periodic properties in the periodic table. So let us consider this table. Okay, first column, periodic property, it is written. In the second column, how it varies in the period. In the third column, how it varies down the group. Okay. So the first one is atomic radius. Atomic radius decreases as we move from left to right in the periodic table and it increases down the group. This is because as we move down the group, number of shells goes on increases. So the distance between nucleus and outermost shell which contains electrons, that goes on increases. So it increases down the group. Second one is ionization energy. It increases across the period and decreases down the group. As we move down the group, number of shells goes on increases, or we can say nuclear charge decreases. If the nuclear charge is less means the last electron is loosely bound to the nucleus, so we can easily remove that electron. So this trend is applicable for all the other periodic properties. So electron affinity, again it increases across the period and it decreases down the group. Electronegativity again increases across the period and decreases down the group. Metallic character. Metallic character, it decreases across the period and increases down the group. Last one is non-metallic character. It increases across the period and decreases down the group. So you consider this table, atomic radius and metallic character. They have the same trend, decreases across the period and increases down the group. All other properties, ionization energy, electron affinity, electronegativity and non-metallic character, they have the same trend. It increases across the period and decreases down the group. Okay, next, the last question. How chemical reactivity varies in the periodic table? So, greater the valency to lose the electron, then greater is the reactivity. This is true in case of metal. Again, greater the tendency to gain the electron, greater is the reactivity. This is for non-metals. So if we move from left to right in the periodic table, chemical reactivity, first it decreases and it becomes least for group 14 elements and then again increases up to group 17. Group 18 elements are not reactive because their valence shell is completely filled, so they are not reactive, inert gases. So we'll consider one example for this. Okay, let us consider period 3 elements. Okay, so elements present in period 3 are sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. These are the elements present in period 3. So consider the first element, sodium. It is the most reactive metal in the third period. Most reactive metal. Again, if we move from magnesium to aluminium, reactivity decreases. Same trend, chemical reactivity decreases least for group 14 and increases up to group 17. Here silicon is group 14, it belongs to group 14, so it is least reactive. Next you consider chlorine. Chlorine is the most reactive non-metal because it has greater tendency to gain the electron in order to complete its octet. Again, if we move from sulfur to phosphorus, chemical reactivity decreases. Okay, this trend is true for all period elements. It decreases least for group 14 elements and increases up to group 17. Okay, this is the answer. If you like my video, please subscribe to my channel and press bell icon to get the notification. Thank you.